Okay, the unbelievably complicated finale. David, Stephen, and Helen are trying to answer the following question. The students in a band have 5 popular and 6 classical music compositions. They're going to play 3 popular and 2 classical, and the order matters. How many different programs? That ruins the surprise just a little bit. Something is wrong with each of these solutions. What is it? 11p5 causes you to lump all the songs together. And that's a problem because you're supposed to do 3 populars and 2 classicals. 11p5 means you consider all the songs the same and you just take 5 of them. That means you could end up playing 5 popular songs, or 5 classical songs, or 4 and 1, or something other than 3 popular, 2 classical. So this one doesn't follow the popular slash classical breakdown that you're supposed to use. It won't give you 3 and 2 unless you get lucky. So David's out. Okay, more complicated selection problems. 5 girls, 7 boys, and we have to select a committee with 2 girls and 3 boys. If that's all there is, then it's just 2 separate selections. We have 5 girls, from which we choose 2, and we have 7 boys, from which we choose 3, and that's it. I generally haven't been working out these numbers, but I'll do this one just in case you want to check up. 7C3 is 35, so there should be 350 ways to select the committees if that's the only criteria. If Johnny the principal's son has to be on the committee, that's a choice taken away from us. Now, when we go to do our choosing, we still have 5 girls, and we still have to select 2 of them. So 5 girls, select 2, that's 10, of course. We know it already. But when you get to the boys, there are only 6 boys now. Johnny's already in the other room, so we only have 6 boys left to choose from. And we don't get to select 3 anymore because we've already got Johnny. He's one of the boys. We only get to select 2 more. 6C2 is 15. So with that choice taken away from us, we only have 150 possible committees now. Now, Peter and Paul can't both be on the committee. Are you thinking what I'm thinking? I believe the cleanest way to do this is going to be find every possible committee and then subtract out the committees that have both Peter and Paul on them. Let's see if we can get it done that way. Our total number of committees is 350. That's every possible one. Now, how many committees are there which do have Peter and Paul? This is just like the committee where they said it's guaranteed that Johnny's on the committee. Here we're saying Peter and Paul are both on the committee. How many choices have you got now? Well, for the girls, again, nothing changes. We still have 5 girls, and we're going to select 2 of them. But when you get to the boys, you don't have 7 boys to choose from now. You only have 5. You've already taken Peter and Paul, so you've only got 5 left to choose from. And for the guys, you only get to select 1. There's only room for 3 boys on the committee, and Peter and Paul are 2 of them. So this is saying, given that Peter and Paul are already in there, you have no choice about it. These are all the choices you get to make. Pick 2 girls and pick 1 more boy to finish out the committee. So that's 350 minus 5C2. I kind of feel like I should be able to do it in my head, but oh well. 10. 5C1 is 5. So we get 350 minus 50 equals 300 committees that don't have both Peter and Paul.